Hello, differential equation students, and welcome back. We are still in unit number 5, and we are still in 6.2. Okay, we are going to do another example over power series and solutions about ordinary points. Okay, and I want to do, it says about x equals 0 for this point. The first thing I should do is I should probably check to make sure that that's ordinary. So I take x squared plus 1 equal to 0. I solve this, and I would get x is equal to plus or minus I, which means these are the singular points, right? And all other points are ordinary. So when I go for 0 here, I'm good with that, right? So I have it centered at 0, and if I wanted to find the radius of convergence, right, 0 until I, plus or minus I, well, that would have a radius of 1, so really we're looking at an interval from -1 to 1, okay, which isn't too bad. Now, remember what we did before. We're assuming that the solution takes on the form n equals 0 to infinity of, well, c sub n, technically x minus a, but since a is 0, we can just write x to the n power, right? So we think that this is the solution, that's why, right? So we did this before, where then we took the derivative of this and we got this thing, right? So that's y prime, and then we took the second one. Wow, that is a very bad summation sign, right? And as we move our way up, we can't have the negative exponent, so we keep dropping our index down, or I should raising it, right? And we get this looking thing. Now what we did before was we plugged it in, right? So if I go to plug these in, I'm taking this y double prime here, so this one here is all of this, right? So I might as well start with that. So I have the summation n equals 2 to infinity of n times n minus 1 c sub n x to the n minus 2. Okay, and then when we looked at it, the original here had this, so I need that x squared plus 1 sitting here. Then I have plus, that's an x times, well, if we go after this and we call that the blue one, right, then I have times the summation as n equals 1 goes to infinity of n x to, or I'm sorry, n c sub n x to the n minus 1. And then finally I have plus, right, and then it's y, well, the y, let's let it be this red part here, that's this, okay, that's that y, which then would be the summation of n equals 0 to infinity c sub n x to the n, that's an n, and it equals 0. Right, now we got it set up. Big thing from here is we need to start trying to simplify this thing down. Which, because I want to keep this all kind of in a line so I can look at it, I'm going to get rid of this part over here so that I can use this as my workspace, because I'm going to need this workspace, I think. Okay. So here what I'm going to do is I'm going to end up distributing like this basically inside, right? So if I distribute the x squared, what happens is this -2 here, they cancel out. So really I have the summation n equals 2 to infinity of n times n minus 1 c sub n x to the n power. Then because I have this plus, oh, well, then I have plus, it's just 1 times that, so really it's just the original thing there in green, which I'm writing out is this thing, right? So hopefully that makes sense there to you. And I use the same type of logic, right? I bring this in, and when I bring it over here to this one, that'll cancel it out. So I have plus the summation as n equals 1 to infinity of n c sub n x to the n. Then this one here has nothing with it, so I can just drop that one down. And I have my new equation, right? So, of course, now's a great time to make sure that you're understanding what's happening. Like if you wanted to pause the video. So what we did before, right, what we did before when we were doing this was we ended up trying to get all of my x to the powers to match. And right now, when you look at it, I mean, they're all pretty close, right? The only one that's giving me some real issue here is this one. Like I would need n minus 2 to equal my k, which means that n equals k plus 2, right? All the other ones, I can get away with just saying like n equals k, n equals k, n equals k, right? So if I replace those, so I have k equals 2 then, infinity, I have k times k minus 1, c sub k, x to the k, plus, now I have a little bit of work to do, right? This n equals this k plus 2, so if I had that, and I were to write the summation, well, it's like a k plus 2 here. Solving that, that's k equals 0 there to infinity of, okay, now n is k plus 2 times, well, that's k plus 2 minus 1, so this is really k plus 1, then c sub k plus 2, x to the k power, plus, and then I get away with, okay, this is k equals 1, k, c sub k, x to the k, plus the summation k equals 0 to infinity of c sub k, x to the k equals 0. Right? So hopefully that all makes sense. That's from kind of the previous couple videos, all right, including 6.1. After that, right, it'd be really nice to be able to combine all of these. The problem is I have some different values, right? I can't make this 2 go down. I can't make it go down into this k equals 0 or this 1, but I can make this k equals 0 come up. I would just need the 0 term, right? And also the first. So if I do k equals 0, that'd be a 2, a 1, so that'd be 2. That'd be c sub 2. And then I have x to the 0, which is just x, right? Or I'm sorry, just 1. So then I have the first, that would be a 3 and a 2, which would make 6. C sub, okay, well, that would be a 3 now. And then that's x. And over here, I would need the first term only. Well, that's 1 then, c sub 1, x to the first. This one here, I'm going to need the 0 and the first. So the 0th term, that would be c sub 0, x to the 0, so really that's just c sub 0. And then I have the first term, well, that would be c sub 1, and then that's x to the first. Now when I go through and I try to finish this now, remember that I'm going to end up piecing all of the summations together now, and then I'm going to put this out front. And I'm going to try to put it in order here. So I have c sub 0. Do I have any other just pure constants? Well, yeah, I do. This one here is plus 2 c sub 2. That's another pure constant, and I think that's it for constants. Then I have plus, I would have this c sub 1x, c sub 1x, well, that's 2 c sub 1s plus c sub 3, and those all have x's, right? Then plus the summation of k equals 0. I'm sorry, not 0. Now they're all to the 2, right? Indice of 2, infinity. And now I'm coming in and I'm just combining these. Remember how I did this before, right? I take the value that's sitting next to them and I'm going to factor out this x to the k, because they do all have this x to the k. Of course, that was our intention, right? So as I'm setting this up, I see a x to the k here. Let me get a different color. Maybe this will help. I see this one has a c sub k, and a c sub k here. I also see this one has a c sub k. So maybe it'd be wise to put those all together. So I have a k times k minus 1 plus a k plus, well, there's only a 1 sitting here. Then that's all times c sub k, right? So I've talked about this section, and this section. I don't have this one, so then I have to put plus. I can write a plus sign. K plus 2 times k plus 1, and then that's c sub k plus 2. Now, all of this has x to the k, and then we have it equal to 0. Okay, now I think is a great time for you to pause the video and see if you can solve this thing the rest of the way through. In fact, I think I'm going to stop this video here. I'm going to pick this example up right here on my next video.